Today I want to talk to you about a POC I've done regarding fine tuning. So this is really around the custom models initiative, which has really two parts in scope. So one is run your own model or bring your own model, where you're able to bring Code Llama or Stablecode, any of these sort of open source models, and connect it up to code suggestions and chat. And the second bit is around model fine tuning. So this is really about getting the model, your data, your code, so that it can then recommend solutions or suggestions based on your code, right? And I guess this applies to both open source and using Google's CodeGecko, Bison, or Anthropic. The only issue is that today Anthropic does not offer any sort of fine tuning API, and even for Google, the API is limited to a few models and does not include CodeGecko. So for this POC, I've mostly focused on open source models. So let's talk about what is the process of fine tuning. So essentially, what we do is we take data out of our code repo. So the customer decides that, hey, I want to fine tune my model based on these following repos, and we create a data set. And then we also take the base model, which is the open source base model, and we then apply something like PEFT, or we apply PEFT, which is parameter efficient fine tuning. And there's a technique within PEFT called QLoRa, which is basically which lets you basically fine tune the model with less resources. And the reason it's able to do that is that when you have a large model, let's say Code Llama could be 70 billion parameters. That's a huge matrix that you're kind of sending around. What LoRa really does is it reduces the matrix to two low rank matrices. So instead of using a very large matrix, you're actually just calculating the changes and in two smaller matrices. And so that what that enables you to do is really tune a few parameters, but then that kind of tunes the whole model. And you multiply essentially those two matrices. But basically, you take the data set and the base model, and then you apply QLoRa on it, and then you get a fine-tuned model that can be used by the customers. So really, when the question that I started out with is it worth fine tuning, right? Is RAG just going to be better? Will we have to give lots of examples to actually fine tune the model? How will that actually work? What kind of resources it needs? So that's what I actually set out to answer. So now I'm going to take you through a notebook that I have that I did fine tuning on Llama 2. So the first thing I did was I did extract all the code from GitLab, from a GitLab monolith code base. I extracted it using tree setter. So what I did was I created this data set and I pushed it to Hugging Face. But basically the data set, if you see, it has the first line of the code and then has the rest of the content, right? And I did this by recursively just going through the whole set of files using tree setter. Now, when I was doing this, I realized that this original set, which has 329K rows, was all of the GitLab monolith code base. It needed too many resources. So it needed something like 200 gigs of VRAM to actually train. And so I wasn't really able to do it with this large data set. So instead, I chose a much smaller data set, which was this GitLab code migrations data set, which is just from a migrations folder. I picked up all the classes, methods, and stuff like that. All right. So this I trained with a much smaller data set, which is about 2,300 or 2,400 rows or so. And that is primarily for the reason of resources. I could fit this into the GPU that I had. So I actually trained this on Google Colab on a single V100 server. I suppose if we get a cluster of GPU machines, we can tune we can tune bigger models, and second, we could probably also train with more data. The setup is really easy. I installed transformers and data sets and a bunch of other things. I installed PEFT, which is important, which has the LoRa settings. So then I import my GitLab code migrations data set, and I split it into both train and test. And the reason is while the model is being tuned, I want to know, how is the training going. I had to log into Hugging Face just because Hugging Face, the Llama 2 models are gated right now. Meta controls the gating of those, and so I had to log in. Now I started with this formatting. So every time you're tuning, you have to format your prompts. So I have to give it a prompt to tune, right? So for every row in that data set, what I do is I create this little prompt, which is, you're an experienced Rail programmer. Could you please complete the code from the line below? I give it the first line, and then I say, hey, the expected response from you is the contents, the remaining contents of the file, right? So that it understands that, hey, I need to return this. And then I started off with the actual model itself. So I got Code Llama. I used the 7 billion parameters version here because that could fit within memory. And I also quantized it to 4 bits. And what basically quantization does is that it enables you to train at a much smaller memory footprint. And so that's what we did. I set up the tokenizer. There's nothing really important here. But then I finally tokenized the prompt. And so basically I took that prompt, I applied it to all the full data set. And then I also tokenized it using the Llama 2 tokenizer so that the model can ingest the data. Also, what I did was I was just checking the tokens that I had to use, and so I could set up maximum tokens. Again, that was pretty easy to do. I set my max length to 512. Again, a lot of this, I'm no expert on fine tuning. A lot of this information I got from a great blog from the people at brev.dev, and it was really useful to use a notebook that they had. Anyway, so you can see that I am tokenizing. I do set things like the beginning of sentence token, so you can see that some tokens are set before the sentence actually starts and stuff like that. So it's tokenized in the right way so that Llama 2 can actually fine tune. Anyway, I'm going to go ahead. So I did the first evaluation, right? So I said, hey, you're an experienced Rails programmer. Could you please complete this? And I gave it some input, which is this one here, right? Saying, hey, can you complete this class? And perhaps this is because it was a pretty quantized model, but it actually didn't even recognize this as Ruby code. So I think it gave me PHP code back as the response, which is quite a bad response to begin with. So the next bit is I set up LoRa, right? So the process of setting up LoRa was to import PEFT, set up the model for training. The most important part is here, where setting the rank and the alpha. So these two are pretty important attributes. The rank, so I said that when you're kind of training the model, we train it in the form of two low rank arrays, that matrices that we multiply, and so this is the rank of each matrix, right? So the higher your rank, theoretically, the more accuracy you have. And the second is alpha, and alpha is an interesting attribute where the weight matrix is scaled by alpha by r. That means that the higher this value, that means that your fine tuning, the data from fine tuning, has more impact, right? And so if you increase this, the fine tuning data would have more impact on your decisions. And the other important factor is this LoRa dropout, which actually determines how much of learned data does it use, right? Is it just going to memorize the data and just spit out the same memorized data, or is it going to actually infer? So that kind of determines it. And from the LoRa paper, that's kind of the recommended amount. I think it's 0.1 for 7B models, but I use this, which seemed to give me okay results. Anyway, so we've got this set up, and then the last part was just to start training. So I trained it in steps of 500. I said, okay, keep evaluating. So based on I had my data set split into train and test. And so I said, okay, after every 50 steps, please evaluate. And you could see that as I ran this, it took about, I would say, an hour and 20 minutes to run or so. And then you could see that the validation loss went from 66% to around 40%. So it did improve the suggestions that it was making over time, right? So that was that. And then once that's done, all I did was restart my notebook, reload the model, apply the PEFT model with the weights, and then try to say, hey, give it the same prompt and say, can you please complete this class? And as you can see the response here you see that it's correctly identified this time. It's Ruby. It's actually used our GitLab database migration class here, and then it's also created like this up thing. So it did the suggestion was a lot better than previous suggestions. Okay, so the last bit really is how do we implement this? It is a bit more complicated, and I'm sure there's many architectures possible here. My thought really was that customers would select a few repositories on gitlab.com. We would have a side kick job that then triggers off a work queue, which then actually goes and trains on GPUs. Once the model is trained, we upload it to GitLab so that the customers can download it and then host it using the Bring Your Own Model framework for custom models. So that's one possible approach. Now it does depend on whether we use kind of a hosted service or whether we are training this on our own GPUs. Another option is that Google Cloud supports managed Kubeflow, and so we could potentially train these on managed Kubeflow, and that's how I think they recommend we train like Bison as well, Code Bison. And so that's one of the thoughts as well. So this is just to take you over my POC. I hope you found this useful. Thank you.